Good morning to all. In this video lecture, I am going to discuss about the topic regulated power supply. In today's scenario, we are utilizing AC power supply for all other commercial application. In specifically, we are dealing with electronics. All electronic components are working with the DC power source. So we are having AC source in all commercial uses. So now we are urged to convert the alternating current source into direct current source with our required level. So normally we are dealing with a single phase system of AC supply 230 volt, but the requirement of DC source is about 9 volt, 10 volt, 12 volt or 5 volt, like that only. So for that we need to convert AC source into DC source with the help of regulated power supply. So what is a regulated power supply? An electronic circuit that produces a stable DC voltage of fixed value across the load terminal irrespective of changes in the load is known as regulated power supply. So the load is changing at any instantaneous of time, but your RPS producing the output DC sources, it should be a fixed one. So that is the purpose of RPS. So this is your block diagram of regulated power supply. So first thing, we are having AC voltage input, and finally we are having steady DC output. How you are going to convert AC voltage input to fixed DC output voltage? So this will be giving the information about the regulated power supply. First thing, we are having AC voltage source, then we are having the transformer, after that we are having rectifier, then we are having filter circuit, then we are having the regulator, then we are having a voltage divider, we are having output finally. Okay, so these steps how we are going to taking care. So first component is step down transformer. So normally we are having 230 volt output. Directly we are going to use 230 volt for the conversion of DC, so that we are going to reduce the 230 volt into some required voltage level. So normally for any electronic circuit they are utilizing 12 volt. So we are using the transformer is a step down transformer. So that step down transformer reduces the voltage from 230 volt to 12 volt AC supply. Okay. So normally, this step down transformer used in the circuit of regulated power supply changes the input voltage to desired lower voltage value. Also, this transformer provides an electrical isolation between two circuits. The reduced output AC voltage of the step down transformer is used as the input to the rectifier circuit. Then second major component is rectifier circuit. So here we are utilizing bridge rectifier for our operation. Okay. So the rectifier circuit is used to convert the input AC voltage into DC voltage. It consists of diode that perform the rectification process, that is the conversion of AC voltage into DC voltage. However, the output of the rectifier is pulsating direct voltage. In practice, full wave rectifier is used as the for the rectification due to its technical advantages. The full wave rectifier can be a center tapped transformer rectifier or a bridge rectifier. So the full wave rectifier converts both positive and negative cycle of AC voltage into DC voltage. So normally we are having several types of rectifier circuit. For simple operation we are going to use the bridge rectifier. So that bridge rectifier is a full bridge converter rectifier. So normally we are having a sinusoidal function, that function having a positive half cycle and negative half cycle. So if you are going with the half wave rectifier, it consider only the positive half cycle for AC circuit supply into DC supply. But in the case of bridge rectifier, it is considered for both positive cycle as well as negative cycle for the conversion of AC supply into DC supply. So after the rectification, we are getting the pulsating DC supply in the output of rectifier. It is not a pure DC supply. Okay. Now we are going to convert this pulsating DC supply into steady DC supply with the help of your filter circuit. So The next major component is filter circuit. The output of the rectifier is a pulsating direct voltage which has very high ripple content. So the raw output of the rectifier is undesirable. So in order to get the pure ripple free voltage, DC voltage, the DC filter circuit is used. So we have different types of filter circuit such as capacitor filter, choke input filter, then pi filter and LC filter. So therefore a filter circuit that converts pulsating direct voltage into the constant direct voltage having the zero ripple current. So after the output of your filter circuit, we are having the constant DC voltage. Now the next component is voltage regulator. The input of voltage regulator is from your filter circuit. The voltage regulator consists of last block of the regulated power supply. So it monitors and correct the fluctuation in the output voltage of the power supply. So the load is changing periodically or instantaneously. So depends upon the load changes, the regulator is monitoring continuously. So what is the level of load at the instantaneous of time. If suppose the load is changing, the regulator is adjusted itself and produces the required fixed DC voltage to the load circuit. Then output voltage may be changes or fluctuate due to any changes in the input AC voltage or change in the load or change in any physical parameter such as temperature of the circuit. So the voltage regulator takes care of this problem. The voltage regulator maintains the DC voltage constant at the output voltage terminal. Then here we are using Zener diode. So Zener diode operates in a Zener region. A transistor series regulator, fixed and variable IC regulators are commonly used in different regulated power supplies as the voltage regulator. Then applications of this regulated power supplies normally using mobile charging circuit, testing circuit, bench power supply, oscillator and amplifier, electronic computers, then automatic system. So thank you for your listening.